my PhD training was at the interface of biology and biological engineering and electrical engineering, where we were looking to integrate ensembles of neurons and build these neural circuits on microelectronic chips. So when I started doing that, then I very quickly realized biological signals are very complex and very small, and tuning and getting what you're looking for is always very challenging. So learned a lot of techniques during grad school, and when I got my own independent job as being an assistant professor running my own program, I was trying to find problems and ideas.
Before we get started, I have a quick favor. I've been self-funding the Finding Genius podcast for 5 years now. I've done over 3,000 episodes, and as you can see on YouTube, we're up over 1 million views on the channel, which is fantastic. The next thing I really want to push on is to get up to 10,000 subscribers, because once we do, we'll be able to put a donate button, and we'll be able to solicit donations to help keep the podcast running and to also get the Finding Genius Foundation moving along. We have a big project studying anxiety, depression, and PTSD, and working on a product to help people overcome these problems, because I've seen them explode recently after the last 2 years of the whole virus situation. So if you would, please subscribe to the podcast. That would help us tremendously. Give us a thumbs up, and check in the description for Buy Me a Coffee. It's about $5. If you could buy me a coffee, I'd really appreciate it. It would help keep the channel going, and I love coffee. Thank you.
Forget frequently asked questions,
common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Hello, this is Richard Jacobs with the Finding Genius Podcast, now part of the Finding Genius Foundation. I have Shalini Prasad, PhD. She's a professor and department head of bioengineering. This is at University of Texas at Dallas. So we're going to talk about sweat. What's in your sweat? Are there wearables that can analyze your sweat and see what's going on with you physically, etc.? So Shalini, thanks so much for coming. How you doing?
I'm good, Rich, and thank you for that nice introduction. Looking forward to chatting with you on sweat, and let's not sweat it together.
And I don't wear we can make so many bad jokes, like I don't wear a sweater. Well, tell me about your background, and then how did you get involved with sweat?
So I'm actually trained as an electrical engineer, and part of that electrical engineering training is always about, decoupling noise from signals, figuring out, signals from the smallest of things, right? So, and of course, in classical electrical engineering, you're thinking of semiconducting microelectronic circuits. However, my PhD training was at the interface of biology and biological engineering and electrical engineering, where we were looking to integrate ensembles of neurons and build these neural circuits on microelectronic chips. So when I started doing that, then I very quickly realized biological signals are very complex and very small, and tuning and getting what you're looking for is always very challenging. So learned a lot of techniques during grad school, and when I got my own independent job as being an assistant professor running my own program, I was trying to find problems and ideas, where we could truly have an impact and improve the quality of human life. So, fast forward till about 7-8 years ago. So I had by then built up a pretty well-established research program, and we were very much focused on looking at building devices for understanding human health. So these are point-of-care devices similar to your blood glucometers, your finger prick blood test, urine test like pregnancy dipstick test, things like that. But looking for other disease indications, like whether is your heart healthy, are you are you doing the right amount of exercise? These are different kinds of questions. Or can you detect cancer early by looking for protein biomarkers, which are cues in your blood, right? So these are the kinds of things we're doing.
I hope you looked into this, but I've always wondered, under the left armpit versus the right, has anyone characterized the differences in people? I would think there's got to be some difference. Maybe a major one, maybe a minor one. And what if a major difference signaled the health problem?
Yes. So this is where it gets very interesting. Like how many cues or like the check engine light can you have, right, to figure out what tie together for a particular disease, right? So is it just heart rate variability? Is it just your elevation to your blood pressure? or is it other things that your body's putting out, like chemicals, biochemicals, molecules? So, and again, it will change based on ethnicities, various demographics, age plays a role, because male, female differences, gender differences, everything, right? So all of this comes together. And so this is when it got like really, right? One thing is very clear. There are about 8 billion people on this planet. People generally don't like to put themselves through pain. It is good to know before you're going to get sick, because the cost burden for healthcare is only going to go up. People are living longer. And so what are ways in which you can make data accessible to people? And people are getting more and more connected because electronics and the ability to use technology is also furthering itself. So there's cool opportunity when you think about it. What can you do if you can make technology, which people are familiar with, as the means or the mechanism to be able to go and look for whether your body's putting out these cues and signals of whether you're getting sick. So this became the kind of the genesis of this idea of going behind what is the easily accessible body fluid, because getting access to blood is not easy. Even a finger prick is painful and people will not comply. So sweat became the opportunity for us to start looking at it. And again, sweat is rich in a bunch of things. So there is mostly fluid, right? Because that's a primary way by which your body cools down. But along the while, because sweat comes out from your interstitial fluid, so this is the fluid which is in between the cells of your epithelial system, so which is your skin. So there is a percolation of what's happening in your circulatory system, so that's your bloodstream, which eventually percolates out. So these are like your cues, right? So this is kind of, now you have to be a detective in terms of what you measure in sweat, and you work your way backward to figure out what's happening within your body. So that was when the aha moment happened, right? Like, here is the opportunity. If you could marry what you can build, these technologies that are highly sensitive to looking for these very small occurring cues, and marry it with basically the smart and wearable tech that is currently ubiquitously available, then you have probably an opportunity for helping people monitor themselves, stay healthy, happy, and fit.
Is there, like, what part of sweat is composed of bacteria? What makes it smell? Is it inorganic compounds, organic compounds? Is it bacteria? What is it?
Yeah, so what makes sweat smell? So there are lots of things that make sweat smell. Yes, absolutely. There are some volatile organic compounds, things like ammonia, right, which is very pungent. Then, of course, you have bacteria that's there as well. And so this, again, by themselves, do not necessarily contribute to as much of that smell factor. And then, of course, there's going to be urea, so which is there as well, the uric acid. And you have a lot of these proteins and lipids that come by. So, but what happens is that bacteria, when it interacts, this sweat will act like a substrate, cause some chemical reactions to occur, and that can trigger, of course, your smell that comes out, right? And it also matters which sweat glands in your body are producing the sweat. So you have what are called eccrine glands and apocrine glands. Apocrine glands are the ones which are very much located like in your armpits, groin. This is the one that actually gives you the more smelly sweat, if you will, because you have a lot more of your oil secretion in conjunction with the bacteria. So together, they make a very potent mix and make things really smelly.
Okay, so if I sweat, I may sweat in various spots of my body. So first of all, are the bacteria coming out from inside our body when we sweat in a certain spot, or are the bacteria there in the skin microbiome, let's say, and the sweat is passing through them, making them wet and activating them in some way? Can you tell what's happening?
Yes. So in that context, right? So yes, it's more so that there is a lot, it's your skin microbiome which triggers. So it is like literally water percolating through, very like lava rock, right? If you think about it, lava rock's very porous, water percolates out, it picks up what's there in the lava rock and it comes out, right? The same idea is used in, this high quality spring water, right? They say it's got a taste because those minerals kind of get into the water and percolates too. Here, same analogy works, but it is more so as it percolates through your skin epithelium, it is interacting with, all the microbes that are there, and then that pretty much pushes it out. You can, of course, have skin infections and other things which will add to it, but that's what's generally driving it. The challenge here, of course, is all of this is what's the interferent, right? Because it's going to hide the cues that you're after or the signals you're after. So the signals are actually your signaling molecules, your inflammatory molecules, these small molecules, proteins, hormones that your body is putting out, which is there in your circulatory system, which is percolating out through your sweat, which is what you want to measure. And you want to measure that dynamically, like how we would do with a wearable. And this allows you then to track your body's health status, if you will, and, be able to take some action. So you have actionable data and kind of work with that.
Before we continue, I've been personally funding the Finding Genius podcast for 4.5 years now, which has led to 2,700 plus interviews of clinicians, researchers, scientists, CEOs, and other amazing people who are working to advance science and improve our lives and our world. Even though this podcast gets 100,000 plus downloads a month, we need your help to reach hundreds of thousands more worldwide. Please visit findinggeniuspodcast.com and click on Support Us. We have 3 levels of membership from $10 to $49 a month, including perks such as the ability to see ahead in our interview calendar and ask questions of upcoming guests, transcripts of podcasts you're interested in, the ability to request specific topics or guests, and more. Visit findinggeniuspodcast.com and click Support Us today. Now back to the show.
Well, you mentioned, for instance, uric acid. So people that are prone to gout or are having a gout episode would a sensor pick this up? It would look at and see, very high levels of uric acid, meaning this person either has or is going to get gout. Would that be an example of analyzing?
Right. So I wish it were as simple, but the premise is true, right? Because our body doesn't have very specific markers to any disease. But yes, a high elevation so you want to track the uric acid in sweat, and you want to see how it goes up and down. And absolutely, as it keeps trending up, then you do understand, then based on that, perhaps you have to have a more detailed diagnostic to figure out what is the key disease indication. Another good example of this is cortisol, right? Cortisol is the hormone that your body puts out. It helps you to regulate your circadian cycle. Generally, we are supposed to have if you're a healthy sleep-wake cycle, your cortisol level will peak early in the morning between 8 and 9 a.m. And then it's going to come down, and, it goes down really at about 2 a.m. and then comes back up, right? So this is kind of allows you, and the melatonin cycle is opposite of this, which would peak, in the evenings, allowing you then to sleep and recharge your body. But all of us live in a highly stressed and connected world, so we have a very dysregulated circadian cycle. So how do we get it back on sync? Right now, the only way to measure cortisol in a non-invasive way is to take a saliva swab, a saliva test, which you can do at home. There are some commercially available things that you can buy and do it, but it's not going to give you much. In reality, you want something that engages with your body and is able to measure this and track this, kind of like you would wear a smartwatch and that keeps telling you, it's tracking your heartbeat and so on, right? So that's the same idea. Now, if you're going after that, then the only way to do that is to measure this from sweat. Then the challenge, of course, is making sure that you're measuring only cortisol and you're not measuring a bunch of other things. There are about 2,000 other different kinds of molecules, messaging molecules, proteins, electrolytes, all kinds of things that's there. Right? So how do you go after what you need is the challenge.
I think sweat presents a very unique opportunity to locally see what's going on, because you mentioned the interstitial fluid percolating outwards through the skin. So sweat on my inner thigh for a certain condition versus under my armpit, or again, left armpit versus right, or, the back of my neck versus my leg. I think it could give very important local information. If I was looking at, and I'm just making this up, I don't know, the ammonia production in sweat from my foot versus my neck versus my armpit, what would that tell you about the condition of my body if you sampled all 3 sites, for instance?
That's a very nice question, right? Because there are 2 things that people are always interested in, right? How body agnostic is this measure, right? And the second thing is, if I get site specific, that this, as you rightly said, whether it's my arm, armpit, groin, whatever, right? Is it going to give me something different? It matters what you're going after. right? That's the key driver to all of this. If you just want to understand whether you're hydrated or not, or whether in the context of cystic fibrosis, you're trying to figure out whether there is an elevation of chloride ions, right? So we collect the sweat and understand that. It generally shouldn't matter which part of the body you're screening this from, right? Now, the big challenge, of course, is are you sampling a sufficient surface of your body to get enough sweat for you to figure this out, right? So that's the first piece to it. The second piece is the location that you've talked about. It is very true that certain parts of our body have a higher sweat gland density than others. And not only is there heterogeneity of this expression, there's also another problem that not all your sweat glands will be active, even though you might have a higher density of sweat glands, right? So you might get an equal volume of sweat from different parts of the body, but the particular target biomarkers, so in this case, it's ammonia or uric acid, when you're measuring that, it can have different concentration profiles. Now, the question becomes exactly what you asked. Hey, what does this tell me? Does this mean that I have a localized issue? So, for example, if it's gout, is it localized on one part of my body versus the other? That's why I see this elevated expression profile. Or is it this is just a measurement artifact or a problem because you're not measuring an apples to apples comparison, right? So the thing is, it is twofold. So this is where the engineering comes in, right? You will have to figure out a way to make all the playing field equal. So you'll have to figure out a way to normalize. So you will have a much higher gland density, 200 glands to 2,000 glands per centimeter square, like 10 times different, right? So then how do you normalize that? And then you have to compare the concentration. You always need to compare that with some standard reference. So for example, when you're studying kidney function, you measure creatinine, right? And everything you report is with respect to that creatinine ratio, which normalizes that kidney function. Similarly, in this case, you can pick an ion and you can measure your target biomarker, in this case, if it's ammonia or uric acid, with respect to, say, a chloride ion, right? So then that helps you understand whether you're truly seeing differences in the measures in different parts of your body, or is it the same? And the answer to this is, if you're then seeing differences, essentially, as you said, site-specific disease indications may exist, which will require, of course, further diagnostic. And you might have, the swelling or this gout on your left side versus your right side, and then you have to or that's where the indicator seems to be. And then you would have to do follow-on testing. But yeah, it is more complex than what it is.
Well, I was mentioning, like they say, when you're going to have a heart attack, it's more the left side and the left arm, and the brachial nerve and all that there that would be affected if you have a heart issue. So I wonder if that would also manifest, again, the nature of the sweat of the left underarm versus the right. Maybe the left being maybe more proximal to some of the nervous system that services the heart would then be different. And maybe there'll be indicators there that you could find. If you found a certain difference between the two, perhaps that would indicate, again, good or bad heart function, for instance.
Very true. And you bring up this very important point, right? Like the relative measures across the two sides of your body, right? And then make an assessment. So systemically, I'll tell you one thing. If you're measuring something which is very well measured, like glucose, right? You do understand when you wear an interstitial body fluid, microneedle kind of a device to measure glucose and compare it to blood glucose measure that's done from a finger prick or a blood draw, right? There is a time difference. It's in the order of minutes, but there's a time difference when what you see in your interstitial fluid and then eventually in sweat maps back to what you see in circulation. Similarly, exactly what you've said, right? So left to right, because you are dealing with this high surface area that our body has, right? And then you have this whole, filtration that has to happen through it. You can get relative differences for the same biomarker that will help you make temporal measurements, which goes to the key point that, you have to build it as a smart wearable that can measure unobtrusively, but in a real-time manner. Because to truly get those cues for the differences, you have to be measuring it dynamically and not like a static sampling like a fingerprint does right now.
Right. Yeah, another interesting anecdote is a friend of mine teaches yoga, and he says that new students, when they sweat, they smell horrible because they're getting out a lot of toxins and things like that out of their body. But some of the positions like kind of squish their organs, and supposedly they get released toxins and things like that from their body. And he said after a few months, they'll smell better if they keep up the practice. They sweat. So it's interesting. That makes me think, the volatiles that come out of someone, how could they be looked at and analyzed to tell the interior condition of the person?
Exactly. So the ability to track metabolomes, right, and doing this with the volatile organic compounds that come out of skin outgassing is a very emerging field, right? And it's a very exciting field. The obvious one that you would do is going to be, as I was alluding to earlier, for liver function or kidney function, right? You're going to look at ammonia, you're going to look at uric acid, urea, and all the various byproducts that come out, from a filtration reaction, right? So you're going to be looking at that. The thing that you make about yoga is actually a very interesting and a cool marketing strategy using a sweat wearable. Because, your standard wearables today will tell you whether your heart function is okay and so on. But this can really tell you using a biochemical footprint or fingerprint, right, where, there is a benefit. So this is like a prognostic, closing the loop using the technology, right, whether this is really working for you, right? So that is an opportunity. Challenge with VOC measurements, though, is that because they're volatile, you have to measure them almost instantaneously. That's the first thing. The second thing is, do you get enough of outgassing, if you will, from the body that the smell can be significant, but in terms of whether the chemical signature is sufficient for you to capture that signal, right, dynamically and put it out there, right? So that's the second challenge that you have with this. But more recently, I would say thanks to COVID, rather, because there has been a lot of work in understanding, especially from breath in that case, what are the various volatiles that map back to perhaps screening for COVID. And this is also some of the work that we have done. But coming back to that is that you can track volatiles. And so hence skin volatiles can be measured equally, efficaciously. The challenge right now is if you're going to sample it like with a patch and then take it and run it through gas chromatography, mass spectrometric column, that's really going to kill the way of integrating it into a well. So then people are not going to use this, right? Then that becomes a very research thing. So how do you take that core idea and apply that to a wearable is going to be, the engineering challenge for us.
Okay. Any other major questions that you're trying to answer by analyzing sweat?
The biggest thing we started when we did this was trying to figure out whether we could track inflammation and infection from sweat. It all started with the premise, right? Before COVID, it was all about the seasonal flu, which kills a lot of people every year, and especially the immunocompromised and the vulnerable, so your pediatric and the geriatric population. So when I had, partnered with this company I co-founded, and we had returned to a proposal to Health and Human Services, or we got this contract to truly see whether we could, from sweat, figure out whether we could measure these signaling molecules, which are cytokines, right, to understand whether if they're starting to increase, can that be an indicator, right, of onset, the infection? Because otherwise people will just say it's allergies and you go about and you're most infectious in your first 72-hour period where you may be asymptomatic or even mildly symptomatic, right? So then you're going to spread it. While we were doing that work, that's when COVID happened. And then there's this all about the cytokine storm that everybody started talking about. So then now you're elevating the problem, right? Like, can I measure the significant elevations of cytokines? And for a person who has been tested positive with COVID, and this is going to tell me whether they're going to have mild case of this disease or a more severe case of this disease. To be able to measure these cytokines, the biggest challenge has been, till date, the only way to collect sweat has been to try to figure out how to get people to do exercise or think of patches, microfluidics to extract our sweat. Anytime you do anything to interact with your sweat gland, you cause a local inflammation of the sweat gland. So what that does is that it basically gives cues back to pretty much your endothelium that, hey, we need to shut down, we are under attack. So what then happens is what squeezes out of the sweat gland is going to be just the liquid, and all this rich metabolite, these proteins, messenger molecules, all of them kind of get left behind through this local inflammatory pathway that kind of gets triggered. So then what you end up getting is you cannot see this thing in sweat. So what we found out, literally like, being a detective and figuring it out, is you need to keep the sweat glands in their happy state. So they need to be like how they would work under, based how in the environment you live in. Once we did that, we were able to go and start seeing the expression profile of these inflammatory molecules towards the idea of targeting or check engine light for infection. And as we did that, we realized we could apply this concept for any chronic disease. So we had partnered then with Crohn's and Colitis Foundation. And what we started looking is there a way to track the inflammatory state of patients with inflammatory bowel disease, which is a painful disease. And it really impacts patients' quality of life. So if we could track them and help them understand how the inflammation is progressing or modulating, then you're giving responses not just to the patient, but to the healthcare provider, and to really help them keep their disease in a managed, controlled state, right? So that's the thing, right? Like, how can you leverage what's there to help track not just how you're performing physiologically, but also you manage your chronic disease? So this is kind of the new areas in which sweat measurements or sweat diagnostics is going. And the beauty is, because that's the case, you can build wearables, and they don't have to be smart watches. They can be any other form of smart, accessories, which can then integrate with the same app ecosystem that we are so used to seeing on our smartphones. And this can keep giving us cues throughout the day. And that hopefully will help us make better choices in how we live our lives, and hopefully manage our diseases so that we have, a very productive life in everything we do.
I was going to joke with you that maybe you should work in Houston instead of Dallas, because it's always so hot and humid. You'll sweat as much as you want over there, fortunately here.
Yes, Rich, that's yes. So the thing that we cracked with engineering was, how do you make that sweat device work in really cold environments, right? When your glands are not going to produce much sweat. It will be a lot easier in Houston, a lot easier in India, where I come from. And the main thing we did was, when we were designing this, was we looked at the idea of the Indian sari, right? The Indian sari, if you look at it closely and you look at its microstructure, so you start taking like a scanning electron micrograph of it, you'll see that the thread pattern and the weave is such that, it will expand and contract depending on how your skin is interacting with it. So if you're sweating a lot, then the pores will increase, and then you have to pull that sweat and dissipate it very quickly. Kind of like how in leaves you see the vasculature in leaves and how that the nutrients get through the uptake. Similarly, if you're not sweating much, right? So then what happens is it makes a nice conformal or a nice, like how a Band-Aid would be on your skin, and it will allow you to pull whatever is there put it into the material. So the same idea, we had to think about to design something that would work, not just in Houston, but hopefully in Alaska. I'm not testing it in Alaska. Maybe one day to go and try it there.
That's funny. One last question. Is there any protocol to maybe put plastic temporarily around someone's leg or waist or whatever, and selectively sweat an area? Maybe put a heat lamp and, again, on some area and plastic or something to make the person sweat, so it could be analyzed, or so that maybe if there's a high concentration of some, molecule that they don't want in that particular area, to sweat it out, like a selective sweat lodge type thing.
Yeah. So can you make people selectively sweat? Yes, you can. Is there a protocol per se? There are protocols to essentially do some form of bandaging, right? Like putting a bandage around and allowing that a selective heating to occur due to changing the relative humidity right there at that interface. But is there something that is standardized? No, this is really the wild, wild west in terms of figuring it out. So if you look at literature and all the scientific literature, people publish protocols where they wrap, multiple inches of the skin. They use things that kind of feel like saran wrap, and sometimes things that look like gauze bandages, right? Like for injuries. So none of them, which works better, right? It's not yet known in that sense, right? But I think what you're asking can be done. I hope in the next 3 to 5 years, we have better protocols that tell us what we need to be doing to get actually actionable, and visually we can see the needle moving one way or the other for the person using this, right? So that's kind of where we are right now.
Okay. Well, Shalini, what's the best way for people to find out more about your work? Where can they go?
You can go on LinkedIn and you can find me, that's one. The other is, of course, shalini.prasad@utdallas.edu if you want to send me an email, or you can follow our lab at BMNL UTD.
Okay, very good. Well, Shalini, thank you. Thank you so much for coming on the podcast. It's a really interesting subject. I don't know, maybe most people wouldn't think sweat is interesting, but I do. So it's been a good call, and thanks so much for being here.
Thank you so much. This has been fun. I enjoyed myself.
Excellent.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.